Hello friends, in this presentation we are talking about the superposition theorem. As we all know that superposition theorem states that in a linear network containing more than one independent source and dependent source, the resultant current in any element is the algebraic sum of the current that would be produced by each independent source acting alone, all the other independent sources being replaced meanwhile by their respective internal resistances. The independent voltage source are represented by their internal resistance if given, or simply short circuit if internal resistances are not mentioned. The independent current source are represented by infinite resistance, that is open circuit. The dependent sources are active at all time. A dependent source has zero value only when its controlled voltage or current is. Steps to be followed in superposition theorem while solving the numericals. First step, find the current through these resistances when only one independent source acting. Replace all the other independent sources by respective internal resistance. Second step shows find the current through the resistance for each of the independent source. Step 3. Find the resultant current through the resistance by the superposition theorem considering the magnitude and the direction of each current. Some practice numericals based on superposition. This numerical shows that we have to find the current flowing through the 1 ohm resistor. So first step, when 4-volt source is acting alone, the circuit looks like 4-volt battery, 1 ampere current source is open circuit and 3 ampere current source is open circuit. So by current division rule, current flowing through the 1 ohm resistor is calculated and the direction of current will be down. Then step 2, when 3 ampere source is acting alone, that time other sources are dead. And again by using current division rule, current flowing through this 1 ohm resistance is calculated. Again the direction is downward. Then in step 3, when 1 ampere source is acting alone, that time other sources, voltage source is short circuit and other current source is open circuit. So the same network can be redrawn to apply the current division rule to find the current flowing through 1 ohm resistor. And hence by using the superposition theorem, the total current is calculated. Next numerical, if dependent source is exist in the numerical, the process will be same. Step 1, when this 30 ampere current source is acting alone, that time 20 volt source is short circuit and dependent voltage source will be exist in the circuit. So to solve them further, we since 30 ampere current source is common in between two meshes, mesh 1 and 2 will form a super mesh. So we have to write the super mesh equation. For that we have to assume the current flowing in each mesh. So say I1 is flowing in mesh 1, which is equal to Ix dash, and I2 is flowing in mesh 2. So now apply KVL to the outer path of super mesh. So according to KVL to the outer path of super mesh, minus 5I1 minus 1I2 minus 4Ix dash. Ix dash can be replaced by I1 and hence equation 3 we will get. Now solving these equation 2 and 3, we will get the value of I1 and I2. I1 is nothing but the Ix dash. Now next step, when 20 volt source is acting alone, again apply KVL to the mesh. So 20 minus 5 Ix double dash minus 1 Ix double dash minus 4 Ix double dash is equal to 0. Since it is the second case, so now the current is represented by double dash. And then third step is by applying a superposition theorem, addition of two currents in step 1 and step 2. So the resultant current is 5 amperes. Next numerical, determine current through 10 ohms resistor. Again, independent source is available in the network. So as usual, step 1, we have to focus only on the independent source. So 100 volt source is acting alone. That time your circuit will look like this: 100 volt, 10 ohm, 10 volt Vx, and Vx current source will be open circuit end. So the Vx which is appearing across the 5 ohm resistor, the value of that Vx is equal to 5 I dash. So now apply KVL to the mesh. 100 minus 10 I dash plus 10 Vx minus 5 I dash, which is equal to 0. And hence the value of I dash is minus 2.86 amperes. Step 2. When 10 ampere source is acting alone, that time voltage source will be short circuited. Then assume two mesh currents I1 and I2 flowing in the network. Then in this case Vx is 5 times I1 minus I2. Then apply KVL to the mesh 1. Minus 10 I1 plus 10 Vx minus 5 I1 minus I2. Arrange this equation to get an equation number 2. Then apply KVL to mesh 2, but in mesh 2 10 ampere current source is present. So I2 is directly equal to minus 10. Solving this equation 2 and 3, then by applying superposition theorem, you will get the final answer. These are the two. Thank you.